Good morning to one and all. Myself Ahimad Kumar, Assistant Professor, Department of Civil Engineering. So today's topic is about design principles of counterfort retaining walls with horizontal backfill. The designing counterfort retaining walls with horizontal backfill involves several important principles and considerations to ensure the stability and functionality of the structure. These walls are commonly used in civil engineering and construction to retain soil, support vertical loads, and prevent soil erosion. Here are some of the key design principles for counterfort retaining walls with horizontal backfill. Coming for the first one is the structure analysis. Conduct a thorough structure analysis to determine the loads the wall will be subjected to, which includes the weight of the backfill, surcharge loads, water pressure, and the seismic forces that are coming onto the wall. Next one, wall height and thickness. The height and thickness of the counterfort retaining wall should be designed to withstand the applied loads. The wall height should be in proportion to the length of the counterforts and the base thickness. Next one is the foundation design. Design a suitable foundation for the wall that can distribute the loads evenly and prevent the settlement. Proper soil investigation is crucial to determine the foundation type, whether it is shallow or deep. Next, counterfort spacing and dimensions. Determining the space and dimensions of the counterforts based on the design loads and the structural analysis. The counterfort should be designed to resist bending and shear forces. Next one is the drainage system. Implement an effective drainage system behind the wall to reduce hydrostatic pressure and prevent water accumulation. This may include weep holes, geotextiles, and drainage pipes. Next one is the stability analysis. Conduct stability analysis such as Rankine or Coulomb methods to ensure that the wall can resist sliding, overturning, and bearing capacity failures under various load conditions. Next one is the geotechnical considerations. Account for soil properties including cohesion, internal friction, and bearing capacity in the design calculations to ensure proper interaction between the wall and the backfill. Next one is the seismic design. Consider seismic forces and design the wall to withstand earthquake loads. This may involve using appropriate seismic design codes and practices. Next one is the aesthetics and finish. Incorporate aesthetics and finishing options that blend the retaining wall with its surroundings and meet any architectural or landscaping requirements. Next one is the construction and quality control. Ensure that construction follows the design specifications and quality control measures are in place to verify the integrity of the wall during and after the constructions. And coming for the cognitive objectives, defining counterfort retaining walls and how they differ from other retaining walls, explanation about lateral earth pressure including how it can be calculated and its significance in retaining wall design, identifying structural components, describing the key structural components of counterfort retaining walls including counterforts, slabs, and footings. Next one is the discuss about the reinforcement, understand the role of steel reinforcement in counterfort retaining walls and how it enhances structural strength. Next one is addressing the drainage considerations, describing the importance of drainage systems in counterfort retaining walls and how they prevent hydrostatic pressure buildup. Next one is the application objectives, designing a counterfort retaining wall, apply the principles and calculations to design a counterfort retaining wall for a specific scenario considering factors like height, spacing, and reinforcement. Select backfill material, choose and specify the appropriate backfill material based on its compaction properties and drainage characteristics. Next one is incorporation of safety factors. Apply safety factors to design parameters to ensure the stability and safety of the retaining wall. Next, consider seismic factors. Integrate seismic considerations into the design of counterfort retaining walls, accounting for potential ground motion and differential settlement. Next one is the effective objectives. Appreciate aesthetic and environmental conditions. Recognize the importance of considering the visual impact and environmental aspects of counterfeit retaining wall design in specific context. Next one is acknowledge the importance of monitoring and maintenance, understand the significance of monitoring and maintaining counterfeit retaining walls to ensure their long-term stability and safety. Next one is the psychometer objectives. Construct a scale model. So creating a scale model or design a digital representation of the counterfeit retaining wall, incorporating the principles and design considerations that are learned. Next one is assessment objectives. Evaluate retaining wall designs. Critically assess and evaluate the effectiveness and the safety of the counterfeit retaining wall designs, identifying potential areas for improvement. So here this session aim is to provide a comprehensive understanding of the principles and guidelines involving in designing counterfeit retaining walls, specifically when horizontal backfill is used. The research or study aims is to encompass several objectives: to educate engineers and professionals in civil engineering and geotechnical engineering on the key principles and best practices for designing counterfeit retaining walls with horizontal backfill, to contribute to the development of safe, stable and cost-effective retaining walls that are specifically designed for horizontal backfill conditions. Thank you.